An electrical permit is generally required for all electrical panel upgrades. It's essential that the work is performed by a licensed electrician, ensuring compliance with the current National Electrical Code, or NEC. During the inspection, the new panel must be appropriately sized for the electrical load. Proper grounding is critical to ensure safety. All required electrical components must be bonded to the panel. The existing wiring must be in good condition and free of damage. All wire connections must be secure and meet code requirements. The wire size must be sufficient to handle the electrical load. Ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or FCIs, may be required for certain circuits. The breakers in the new panel must be of the correct amperage and trip type for the circuits they protect. Surge protection devices may be inspected if installed. High-power appliances, such as air conditioners or electric ranges, may require dedicated circuits or subpanels. Some inspectors may require a load calculation to determine the appropriate panel size. Older homes may have knob and tube wiring or other issues that require additional work. If significant wiring upgrades are required, the inspector may request a rewiring inspection. The cost of a panel upgrade can vary widely depending on the size of the panel, the complexity of the wiring, and any additional repairs or upgrades needed. To determine a realistic budget, it's important to get multiple quotes from licensed electricians. Consider the potential costs of additional wiring upgrades, if necessary. Hire a reputable electrician with experience in panel upgrades. Schedule an informal inspection with the inspector before the work begins to discuss any potential issues. Maintain a record of the work performed, including permits, inspections, and warranties. Firstly, the inspector will verify that a permit was obtained for the electrical panel upgrade. Secondly, they'll confirm that a licensed electrician performed the work. Thirdly, they'll ensure compliance with the current National Electrical Code, or NEC. Fourthly, the inspector will check that the new panel is appropriately sized for the electrical load to prevent overloading and potential hazards. Fifthly, proper grounding of the panel is a crucial safety measure to protect against electrical shock. Sixthly, all required electrical components must be properly bonded to the panel to maintain electrical continuity. Seventhly, the inspector will assess the condition of the existing wiring, ensuring it is free from damage and in good working order. Eighthly, all wire connections must be secure and meet the code requirements to prevent loose connections and potential fires. Ninthly, the wire size must be sufficient to handle the electrical load to prevent overheating and voltage drop. Tenthly, the inspector will determine if ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or FCIs, are required for certain circuits to provide additional safety. 11thly, the breakers in the new panel must be of the correct amperage and trip type for the circuits they protect, ensuring proper overcurrent protection. 12thly, if surge protection devices are installed, they will be inspected to ensure they are functioning correctly. 13thly, the inspector will check if high-power appliances, such as air conditioners or electric ranges, require dedicated circuits or subpanels to handle their electrical demand. 14thly, some inspectors may require a load calculation to determine the appropriate panel size, especially in older homes. 15thly, older homes may have knob and tube wiring or other issues that require additional work to meet current safety standards. 16thly, if significant wiring upgrades are required, the inspector may request a rewiring inspection to ensure the entire electrical system is safe and up to code. The inspection typically covers several key areas. 1. The panel installation itself. This includes ensuring the panel is properly mounted, secured, and located in an accessible area. 2. The grounding and bonding. The inspector will verify that the panel is properly grounded to a grounding electrode system and that all metallic components are bonded together to create a low impedance path for fault currents. 3. The wiring connections. The inspector will check that all wiring connections are properly made, secured, and insulated to prevent shorts and ground faults. 4. The overcurrent protection. The inspector will ensure that the circuit breakers or fuses are the correct size and type for the circuits they protect, and that they are properly labeled. 5. The ground fault circuit interrupter, or GFCI, and arc fault circuit interrupter, or SCI, protection. The inspector will verify that GFCIs are installed in areas where required by code, such as bathrooms and kitchens, and that SCIs are installed in areas where required by code, such as bedrooms. 6. The general condition of the wiring. The inspector will visually inspect the existing wiring to identify any signs of damage, deterioration, or improper installation. If any issues are found, the inspector may require them to be corrected before approving the installation. Knob and tube wiring is an outdated wiring method that is commonly found in older homes. It consists of single insulated wires that are supported by porcelain knobs and tubes. Knob and tube wiring is generally considered to be safe if it is in good condition and has been properly installed. However, it is more vulnerable to damage and deterioration than modern wiring methods. If the inspector finds knob and tube wiring, they may require it to be replaced or upgraded to meet current safety standards. The decision to replace or upgrade knob and tube wiring will depend on a number of factors, including the condition of the wiring, the age of the home, and the local building codes. In some cases, it may be possible to leave the knob and tube wiring in place if it is in good condition and the home is not undergoing any major renovations. However, it is generally recommended to replace or upgrade knob and tube wiring whenever possible to improve the safety and reliability of the electrical system. The inspector may also check for other potential electrical hazards such as overloaded circuits, exposed wiring, and damaged outlets or switches. Any hazards that are found must be corrected before the installation can be approved. Hiring a qualified and experienced electrician is essential for ensuring that the electrical panel upgrade is performed safely and correctly. A licensed electrician will be familiar with the local building codes and the National Electrical Code, or NEC, and will be able to identify and correct any potential electrical hazards. The electrician should also be able to provide a written estimate for the cost of the work, and should be able to answer any questions about the installation process. Before hiring an electrician, it is a good idea to check their references and to make sure they are properly licensed and insured. The cost of an electrical panel upgrade can vary depending on a number of factors, including the size of the panel, the complexity of the wiring, and the location of the home. However, it is generally a good idea to budget at least $1,000 to $2,000 for the project. It is also important to factor in the cost of any additional wiring upgrades that may be required. If the existing wiring is old or damaged, it may need to be replaced to meet current safety standards. This can add significantly to the cost of the project. If the inspector requires additional work to be performed, it is important to get a written estimate from the electrician before proceeding. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. The electrician should also be able to answer any questions about the additional work and how it will affect the overall cost of the project. Keeping a record of all the work performed, including permits, inspections, and warranties, is important for future reference. This information may be needed for insurance purposes or when selling the home. The permit will show that the work was performed legally and that it meets the local building codes. The inspection report will show that the electrical system has been inspected by a qualified inspector and that it is safe to operate. The warranties will provide coverage for any defects in the materials or workmanship. By following these tips, it can be ensured that the electrical panel upgrade is performed safely and correctly, and that the electrical system is up to code. Firstly, you need to obtain an electrical permit for the panel upgrade. Secondly, ensure a licensed electrician does the work. Thirdly, the new panel and wiring must comply with the current National Electrical Code, or NEC. Fourthly, the new panel must be appropriately sized for the electrical load. Fifthly, proper grounding is required for safety. Sixthly, all required electrical components must be bonded to the panel. Seventhly, the existing wiring must be in good condition and free of damage. Eighthly, all wire connections must be secure and meet code requirements. Ninthly, a wire size must be sufficient to handle the electrical load. Tenthly, ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, may be required for certain circuits. 11thly, the breakers in the new panel must be of the correct amperage and trip type for the circuits they protect. 12thly, surge protection devices may be inspected if installed. 13thly, high-power appliances, such as air conditioners and electric ranges, may require dedicated circuits or subpanels. 14thly, some inspectors may require a load calculation to determine the appropriate panel size. 15thly, older homes may have knob and tube wiring or other issues that require additional work. 16thly, if significant wiring upgrades are required, the inspector may request a rewiring inspection. When budgeting for the upgrade, get multiple quotes from licensed electricians. Consider the potential costs of additional wiring upgrades, if necessary. It is advisable to hire a reputable electrician with experience in panel upgrades. You may want to schedule an informal inspection with the inspector before the work begins to discuss any potential issues. It is also important to keep a record of the work performed, including permits, inspections, and warranties. The cost of a panel upgrade can vary widely. The size of the panel is a factor. The complexity of the wiring can increase the cost. Any additional repairs or upgrades needed will also affect the final price. Consider the potential costs of additional wiring upgrades when budgeting. An informal inspection with your local inspector before the work begins can help identify potential issues and prevent surprises later on. Grounding is a critical safety aspect of electrical systems. It provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and to energize the circuit. Without proper grounding, a fault current could flow through a person or object, causing electrical shock or fire. Bonding is the process of connecting all metallic parts of an electrical system together to create a low impedance path for fault current. This helps to ensure that all metallic parts are at the same potential, which reduces the risk of electrical shock. The National Electrical Code, or NEC, specifies the requirements for grounding and bonding in electrical systems. These requirements are designed to protect people and property from electrical hazards. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. They work by monitoring the current flowing through a circuit and detecting any imbalances. If an imbalance is detected, the GFCI will trip and de-energize the circuit. Ground fault circuit interrupters, or GFCIs, are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or RFCIs, are devices that are designed to protect against electrical fires. They work by detecting arc faults, which are small electrical sparks that can occur in damage to worn wiring. If an arc fault is detected, the RFCI will trip and energize the circuit. Arc fault circuit interrupters, or RFCIs, are required in areas where there is a high risk of electrical fires, such as bedrooms and living rooms. Surge protection devices are devices that are designed to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy electronic devices. Surge protection devices work by diverting the excess voltage away from the protected equipment. Surge protection devices are recommended for all homes and businesses, especially those that have sensitive electronic equipment. Load calculations are used to determine the appropriate size of an electrical panel for a building. The load calculation takes into account the total electrical load of the building, including the lighting, appliances, and other electrical equipment. The electrical panel must be sized to handle the total electrical load of the building. Knob and tube wiring is an outdated wiring method that is no longer permitted in new construction. However, it is still found in many older homes. Knob and tube wiring is generally considered to be safe if it is in good condition and has been properly installed. However, it is more vulnerable to damage and deterioration than modern wiring methods. If knob and tube wiring is found during an electrical inspection, it may be required to be replaced or upgraded to meet current safety standards. Electrical panels typically need to be upgraded for several reasons. Firstly, if the existing panel is old or outdated, it may not be able to handle the electrical load of the modern home. Secondly, if the panel is undersized, it may not be able to provide enough power to all of the electrical circuits in the home. Thirdly, if the panel is damaged or deteriorated, it may pose a safety hazard. Fourthly, upgrading an electrical panel can improve the safety and reliability of the electrical system. Fifthly, a new electrical panel can increase the value of the home. The process of upgrading an electrical panel typically involves several steps. Firstly, obtaining an electrical permit from the local building department. Secondly, disconnecting the power to the existing panel. Thirdly, removing the old panel. Fourthly, installing the new panel. Fifthly, connecting the wiring to the new panel. Sixthly, inspecting the installation. Seventhly, restoring power to the panel. When choosing an electrician to upgrade an electrical panel, it is important to consider several factors. Firstly, make sure the electrician is licensed and insured. Secondly, get multiple quotes from different electricians. Thirdly, check the electrician's references. Fourthly, ask the electrician about their experience with panel upgrades. Fifthly, make sure the electrician is familiar with the local building codes. When budgeting for an electrical panel upgrade, it is important to consider the following costs. Firstly, the cost of the electrical permit. Secondly, the cost of the new electrical panel. Thirdly, the cost of the wiring and other materials. Fourthly, the cost of the electrician's labor. Fifthly, the cost of any additional work that may be required, such as replacing old wiring. Electrical inspections are an important part of ensuring the safety of homes and businesses. They help to identify potential electrical hazards and to ensure that electrical systems are installed and maintained properly. Electrical inspectors are trained professionals who are familiar with the local building codes and the National Electrical Code, or NEC. They are able to identify potential electrical hazards and to recommend corrective action. Electrical inspections are typically required for new construction, renovations, and electrical panel upgrades. They may also be required for other types of electrical work, such as installing a new electrical outlet or wiring a new appliance. Electrical inspections typically cover several key areas. 1. The electrical panel. 2. The wiring. 3. The outlets and switches. 4. The lighting fixtures. 5. The appliances. 6. The grounding system. 7. The bonding system. During an electrical inspection, the inspector will look for potential electrical hazards such as overloaded circuits, damaged wiring, and improper grounding. They will also check to make sure that the electrical system is installed and maintained properly. If the inspector finds any electrical hazards, they will require them to be corrected before approving the installation. The cost of an electrical inspection can vary depending on the size and complexity of the electrical system. However, it is generally a good idea to budget at least a few $100s for the inspection. The electrical system is a critical part of any home or business. It is important to have it inspected regularly to ensure that it is safe and up to code. A properly functioning electrical system can help to prevent electrical fires, electrical shock, and other electrical hazards. It can also help to improve the efficiency of the electrical system and to reduce energy costs. Regularly inspecting the electrical system is an investment in safety and peace of mind. It is a way to protect family, employees, and property from electrical hazards. It can also help to save money on energy costs and to extend the life of electrical equipment. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. It is developed and published by the National Fire Protection Association, or NFPA. The National Electrical Code, or NEC, is updated every 3 years. The latest edition of the National Electrical Code, or NEC, is the 2023 edition. The National Electrical Code, or NEC, is widely adopted by state and local governments. It is also used by insurance companies and other organizations. The National Electrical Code, or NEC, covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and bonding. It also includes requirements for specific types of electrical equipment, such as lighting fixtures, appliances, and motors. The National Electrical Code, or NEC, is an important resource for electricians, electrical inspectors, and other professionals who work with electrical systems. It provides the information they need to install and maintain electrical systems safely and effectively. If you are planning to do any electrical work, it is important to consult the National Electrical Code, or NEC, and to follow all of the applicable requirements. This will help to ensure that the work is done safely and that the electrical system is up to code. The NEC is a comprehensive document, and it can be difficult to understand without some training. If you are not familiar with the NEC, it is best to hire a qualified electrician to do the electrical work. They will be able to ensure that the work is done safely and that it meets all of the applicable requirements.